Hey class, Mr. Husted here. Today's exciting episode of Geometry Notes is going to be a little more geometry focused, or I'm sorry, a little more algebra focused, as we are going to be talking about slopes of lines and what that tells us about parallel and perpendicular lines. So hopefully you remember back to algebra last year, and the slope is nothing more than the ratio of vertical change to horizontal change between any 2 points, or as some of us like to call it, we call that rise over run. We're going to put a little formula to it here in just a second. Actually, I think, yep, there it is. M is what we use as an abbreviation for slope. I don't know. There's no M in slope, at least not that I've found. But it's rise over run, change in y's over change in x. And if we have the 2 points, if we just subtract the y coordinates and subtract the x coordinates, that can give us our slope. Okay, so nothing to really put in your notes here, but just to talk about positive, negative, undefined, and zero slopes. A negative slope, everything we do, we read left to right. So when we read left to right on a line, if we start here, and if it looks like it's going downhill, that's going to be our negative slope. If we look left to right and it looks like it's going uphill, that's going to be a positive slope. Going up the hill is positive, going down the hill is negative. A zero slope is a horizontal line. A horizontal line is it goes from left to right. And basically it's a zero slope because it's going to be, it's going to be 0 over, infinity. It runs forever, or whatever 2 points you pick. It's not going to rise, but it's going to run. And then you have a vertical line here, which will be an undefined slope because, again, it's like the flip of that one. It's, it's going to rise forever, but it's never going to run. So you're going to get infinity over 0, which if you plug that in your calculator will always give you an error. So we don't like to see that. Okay, so the first thing we're going to do is we're just going to calculate slope. We're going to take it between 2 points, and we're going to figure out what our slope is. So our first one we're going to do here is slope A, or I'm sorry, line A. We're going to look for the slope of line A. So if I'm looking over here at line A, that's this one right here. Okay, my 2 points are right here and right here. So just a little refresher, we have 6, 4, and we have 8, 2. Just a reminder, this is my x, this is my y, this is x, this is y. I would go through and I'd even mark them so you know. And then remember, slope is change in y's over change in x. So we will do 2 minus 4, and then we'll do 8 minus 6. The key here is making sure that these two numbers here come from the same point, and these two numbers here come from the same point. We can't cross it up. We have to have them coming from the same point in order to get the proper slope. So this will give us negative 2 over positive 2, resulting in a final answer of negative 1 over 1, or just a negative 1. Okay, so that means every time we go down 1, we're going to go to the right 1. Okay, so that was line A. Line D, in this case, line D is right here. So we are going to use the points 6, 4 again, and we'll use the point 6, 0. Now I could use any point along here. Okay, the key in finding slope and not getting not getting weird decimals or anything like that is to use points that kind of cross those blue lines. If we cross those blue lines, then we'll get whole numbers, which will help us get whole number answers then too. So again, x sub 1, y sub 1, x sub 2, y sub 2. I want to show you that it doesn't matter which x or y we start with. As long as we're consistent, we will get the same answer. So this time I'm going to do 4 minus 0. So I'm going to start with my y1, and then I'll do 6 minus 6. So that's going to give me 4 over 0. And if you remember up here, to any time we get 0 in the denominator, that is a vertical line, which means we will have an undefined slope. Didn't even need to do all that work. This is a vertical line going straight up and down, so whenever that happens, it's always going to be undefined. Okay, so postulates, two more postulates to add. Okay, in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. So key here, this is a biconditional. They will be parallel if they have the same slope. So if they both have -2 or +5 or 2/3, but the slopes have to be the same. Okay. For perpendicular lines, two non-vertical lines are perpendicular if and only if their product, the product of their slopes is -1. Now what that means, and the way I kind of look at it, is if the slope of one line is, say, maybe 1/2, so that's the slope of line 1, the slope of line 2, to be perpendicular to that, we will flip it as a reciprocal and we will change its sign. So if one is 1/2, the other one has to be flipped, and we have to change the sign of that number. Okay? All right, let's flip over to the side. What we're going to do here in example number 2 is we're just going to identify if lines are parallel. Again, this is something we have to do. We have to actually find the slope of each line to determine that. So we will start with K1. We'll find the slope of line K1. We have our x and our y, our x and our y. So I'm going to do 0 minus 4 over -3 minus -2. It's going to give me a -4 on top. That should be -2. This is going to be -3 plus +2, which will give me a -1. The two negatives will cancel out and give me just a +4. If you're ever questioning that, again, as we look from left to right, this looks like it's going uphill, which will make it positive. Okay, K2, I'm going to do 1 minus 5 over 3 minus 4. That's going to give me -4 over -1, which will be +4 again. And then finally, we'll do K3. And we'll do -2 minus 3 over 5 minus 6. -2 minus 3 is -5 over -1, which will give me a +5 as a slope. So again, in order to be parallel, they have to be, we have to have equal slopes. So obviously, if we look at this, we see that the slope of K1 and K2 are equal. Therefore, we can make a statement saying that K1 is parallel to K2. Any questions on that? Again, just some simple algebra. Okay, so now we're going to draw a perpendicular line. We want to line H passes through the points 3, 0, and 7, 6. We're going to graph a line perpendicular to H that passes through the point 2, 5. So let's graph the first one that we have. So 3, 0. So here, and 7, 6. Okay, so we have a line that goes there. I'll try to draw my line as straight as possible. Actually, that's not too bad. Pretty proud of that one. Okay. Before we do that, let's do anything else. Let's figure out the slope here. So that'd be 6 minus 0 over 7 minus 3. So we get 6 over 4, which is 3 over 2. We want to leave that as an improper fraction. Okay, remember, to be perpendicular to, we need to flip the slope. So we'll call this slope M1. To figure out the slope of M2, we're simply going to flip it and change the sign. So now we're doing a -2/3. Okay, so the point passes through 2, 5. So let's graph 2, 5. And then we'll just use our slope to plot a couple more points to figure out where they will intersect. So -2, 3, just a reminder, rise over run. If it's negative, we're going to go down and then but we're always going to run to our right. So in this case, it's going to go down 2 and over 3. And as you can see, those lines will intersect right there. So those lines would be perpendicular to, in fact, to the point where we can even put a right angle measure there. Okay, so hopefully you understand a little bit more about parallel and perpendicular lines and what they look like and algebraically, and how we can use that. We're going to use that for more proofs and stuff like that moving forward. So if you have any questions, bring them with you to class, and we will see you then.